The next type of valves we're going to look at are directional control valves. They essentially allow fluid to flow through a variety of different paths. The simplest type is our check valves, sometimes referred to as one-way valves. Essentially, the way check valves work is if fluid is coming in this direction, it's going to push against this ball. By the way, the symbol shows a ball, but this could be a poppet valve. This could be a piston. It's just the symbol that uses it, and it's not going to allow flow. On the other hand, if fluid comes in this direction, it's going to push this ball out and fluid is going to flow around it. Right, so this is one thing to be careful about check valves. The drawing themselves has an arrow, and it turns out that the arrow, of course, represents that ball valve mechanism. It does not represent the direction of flow. And in fact, the direction of flow, the allowable direction of flow in a check valve is opposite this arrow. In addition, we can have two-way valves. Two-way valves essentially allow flow in either direction. A two-way valve could be this multi-positional one that we could slide it back and forth, or a shut-off valve. And shut-off valves can be in a variety of formats. We'll take a look at those. We can also have three-way valves where there's 3 ports connected here, or four-way valves where there's 4 ports connected. And these are all different mechanisms for changing how fluid is routed through the circuits. Start with shut-off valves. They're the most basic devices that we're going to see to control flow. Essentially, they open or close. So some mechanisms are going to fall in place to block that fluid. The idea is oftentimes they're manual, and you can shut off one portion of the circuit, perhaps during maintenance or if you're replacing a component, etc. And what you have is one passageway, and it connects an inlet and an outlet port. There are a number of different devices. Here are just 3 examples. We can have what is referred to as a globe valve. This is essentially a type of poppet where the fluid is going to flow through here, and the globe or disc is going to press down into here and open and close it. A gate valve, same idea, but we have a linear device that slides in and out and blocks the gate. Also have ball valves. Essentially, we have a ball here with a hole through the middle. If you rotate the ball and line the holes up, it allows flow. If you rotate it 90 degrees, it's going to block flow. Right. There are many different types of shut-off valves used in the hydraulic industry, but also used in a variety of other industries as well. And these are the main 3 types. If you want more complicated control, you can use a spool valve. Right, this has a spool in here. This actually looks like the spool for thread, and they'll slide back and forth with this lever. In this normal position or open position, the fluid is going to go right in the inlet and the outlet. If you slide this lever over, it's going to move the spool, and that spool area, that wider area of the spool, is going to block the flow. Right, so this can be done with a lever control. This works very nicely with automation, with a solenoid, for example. So there's a variety of reasons why you may want to use a spool valve. Lastly, let's mention needle valves. Needle valves can be used to control flow if they're partially open, but of course you can crank them all the way down and shut off the valve as well. Keep in mind with needle valves, they're usually designed to only work in one direction. That's with fluid coming in and going out. Keep in mind the needle itself is a relatively delicate piece of equipment. We don't want fluid to come in and push on the needle valve that potentially could damage it, bend it, etc., and prevent it from functioning correctly. Next type of valves are check valves, sometimes referred to as one-way valves, and they're essentially allowed to allow fluid to flow in one direction and prevent fluid from flowing in other directions. We see check valves all over the place in hydraulics. They're built into many of the pumps we talked about. They're internal to a lot of our other valves and devices, and they can be relatively complex. For example, they can work with be variable, so open and close a certain amount and act to restrict flow. They can also be controlled by pilot pressure. And in fact, one of the things we often do with these is we may use pilot pressure from another portion of the circuit to actuate, essentially open the check valve. right? So as I mentioned, they're used in a wide variety of different functions, essentially do the same thing, only mean opening and closing and allowing flow and not allowing flow, but depending on how they're set up, they can do different things in different devices, and oftentimes they're integral to other devices. If you take a look, here's a standard setup here. This is a ball valve. It's going to have a light spring back here to keep it closed. If fluid comes along and presses on the valve, that's going to compress the spring and allow it to flow. On the other hand, if fluid comes in this direction, it's going to push on this ball and seat it. Right, so it's not going to allow the flow. The spring is not designed to be any type of pressure control. It's a very lightweight spring, just designed to basically hold the ball in place. We can also do this with a piston arrangement or a poppet arrangement, so the device itself isn't particularly important. These ones will allow flow in one direction, known as free flow, and then in the other direction, it's going to be blocked. As I mentioned, we can also build in restriction in check valves to actually allow it to actually work as a flow control device. If you take a look at this one down here, you'll notice it has an orifice drilled through the poppet. Essentially, when it receives fluid pressure on this side, it acts just like a standard check valve and will open. On the other hand, when it has pressurized fluid on the opposite side, the fluid will actually leak slowly through the orifice, and you'll get a small amount of flow, a small amount of metered flow that through the device. So it functions as a check valve and a flow control valve in the same one. These are used in a few different locations. One common one is in large forming presses, where you want full flow to actually press down on it, but then we want it to retract relatively slowly. So this restricted metered flow will retract it slowly in a safe way. Another place where these are used is if you have large hydraulic systems that need to be drained out when they're done. You essentially use this check valve, especially the metered flow, to slowly drain out the system. Now, these can be operated directly, as we've shown, but they can also take advantage of pilot pressure. If you take a look at these actually have pilot pressure coming in from the side. This is attached to a piston arrangement that will open the valve. So in this case here, we're going to get free flow in this direction. We're going to have block flow in this direction normally, but if you have pilot pressure, it can pop this open and allow flow. So you'll get free flow with pilot pressure. Right? These can be set up to prevent flow in either direction. So for example, this one is set up to allow flow backwards through here. This one is actually going to prevent flow in this case. So if you do have pilot pressure on here, this is going to keep this poppet seated and not allow flow to go through in this direction. So we can allow pilot pressure to open a valve, but keep in mind we can also allow pilot pressure to hold a valve closed. The next of the directional control valves we're going to look at are three-way valves. They're referred to as three waves because they have 3 ports, right? If we take a look, we have a reservoir, and we have pump flow, and we have actuators with 3 separator ports. The traditional use of these is for extending and retracting single acting cylinders or hydraulic rams, right? So in this normal position here, we have our pump flow is going to be blocked, right? This is attached to our actuator, and essentially this allows us to drain out the actuator. So in the normal position, we wouldn't have any fluid flowing into the actuator. When we want the actuator to extend, we move this lever. This slides this spool, and the flow from the pump goes now right to the actuator and will extend it. Once the actuator is extended, we want to retract it, move it back to the other position, and the fluid drains back out. Now, keep in mind, we can do a number of different things with three-way valves. This is just the most common one. You could also, for example, operate motors and things like that, but those generally are done with four-way valves. Here's an example of an application of a four-way valve. This is a double acting cylinder. We want it to be able to extend and retract. And that way we need to have an additional path. So anytime we're dealing with a double acting cylinder or a hydraulic motor, we're very likely going to need a four-way valve. And keep in mind, when we talk about double acting cylinders, keep in mind that single acting cylinders move in both directions. Double acting cylinders, you have control of the movement in both directions. And most importantly, you have control of the amount of force you can put out in both directions. Now, in a four-way valve, you can have 4 ports. They're going to be connected to the pump, the reservoir, and the inlet and outlet lines of the actuator. Right. Here's the general setup. We'll see the ports. T is short for tank, and that's generally used for reservoir. P is used for pumps, and then we have ports A and B. This is another one of these spool valves. There's a spring, so it goes back to the center position. If you push the lever in one direction, it connects the fluid to the A side, okay, and the pump fluid is going to go to probably extend the cylinder. Keep in mind the B side is attached to the tank. So as the cylinder extends, the fluid on the blind side is going to come back and be pushed back to the reservoir. We then wanted to retract the cylinder. We actuate this lever. Now the pump is connected to the blind side of our cylinder. It's going to be pushing the fluid back, and then our other side is going to drain out to the reservoir. Right? This is just one example. We can also do this with a hydraulic motor if we want to reverse it from clockwise to counterclockwise, etc., or any type of situation where we want to control a function going back and forth. These four-way valves are effective for that mechanism. Depending on what you want to have happen when the valve is unactuated. So in the normal position, you can have different types of centers. So for example, if you wanted to have all of the ports disconnected, essentially blocked off, you could have a closed center. If you wanted to have all of the ports connected together, you can have an open center. A tandem center essentially allows the pump to be unloaded when it's not actuated, so the fluid goes directly from the pump back to the T, right? Remember, T is short for reservoir. Kind of an odd one. On wish they had gone with R, but T for tank, if you want to try to memorize it that way. We also have what's referred to as a float center. A float center essentially allows the cylinder or the motor to float or move on its own when it's in the center position. And we have regeneration. The way regeneration works is as we extend our cylinder, the retracting fluid is going to, the fluid on the far side is going to come around and use to help extend it. So it's allowed it to regenerate. So these are the common designs. You could potentially see other ones. It all depends on what you want the fluid to do when the valve is in its center position. So these can do a variety of different things, and generally this is when the system is just starting up, or if the system is just idling, your cylinder's not really doing anything, or when the system is actually stopped. So in terms of actually operating these valves, or what's known as actuating these valves, we have a variety of different controls, something as simple as self-actuating or manual actuating to relatively complicated electrical controls. They generally fall in 5 categories, however. One, if you use the flow of fluid to actually activate it. We can also have manually operated ones, things like buttons, levers, etc. We can use pilot pressure from other ports of the circuit, or even internal pilot pressure. We have a number of electrical devices that can move the valve back and forth. And then, of course, we have situations where we want the valve not to move. So we have controls that are specific for just holding it in its position. One thing that's important to note is it's not one or the other. In fact, we can have multiple methods. They can be combined. So, for example, you could use pilot operation and manual operation. They could be or, for example, you could have manual operation or pilot. Either one of them could operate it. And in some situations, you even may have 3 or even 4 different controls working together. If you want, for example, pilot operated with manual, and you want it to be held, and then you want spring return, for example. That's a common combination where you might have as many as 4 different controls for operating the actual valve. So fluid flow is essentially the simplest one. If you have fluid flowing, you actuate the valve. And a good example of that is a check valve. Essentially, check valves are closed until fluid flows against them, and that opens the valve. We don't see this being used very much in other valve types. Works in terms of flow control valves, but you don't really use flow activation in many of the other valves. So you don't see it in pressure control valves or directional control valves. Manual operation, however, is essentially all over the place. You can use a variety of different devices to operate the valve, levers, push buttons, hand wheels where you're actually cranking the valve. A number of different automated equipment actually uses foot pedals, with the idea being that the operator's hands are doing something else, and we use a foot pedal to actuate the piece of equipment. And keep in mind, these can be used in essentially every one of our valves. A number of different directional control valves, and you can actually see them also used in flow control valves and pressure controls to a lesser extent. And usually those are designed mostly for adjustments rather than for actual primary operation. In terms of mechanical operation, we can use a number of devices that essentially sense other types of motion. So we can mechanically connect one valve to another function. So for example, this is an example of a roller mechanism. It would be connected to potentially a cylinder extending. When that cylinder extended, it would push this open. Right? This is kind of old school automation where we actually use the mechanical motion of the device to control other parts. Many of those in modern equipment are replaced by solenoid controls where there's computer controls and things like that. Then you can actually monitor it and control it. But these types of manual operations can use a variety of mechanical devices, it says rollers, cams, levers, rams, etc., to open and close valves. And it's still used where it's essentially has built-in feedback. You don't have to actually have any kind of sensing device. The manual operation of one device operates the other. Pilot operated is used all over the place. Essentially, you're going to use the fluid pressure to open and close valves. It can be done as the primary control, right? So essentially just pushing directly on the valve. But it's also done in a lot of situations where you have multi-stage valves, where you use that smaller directional control valve or pressure control valve that then controls the main valve. And as I said, you can use this in obviously there's the single stage ones, the double stage ones, but you can even see 3 or even 4 stages if you want to control larger and larger valves. If we take a look at a directional control valve, right, this is example down here is a 4-way valve. This has solenoids on either side, and what you see up here is you see the pilot valve right up here. And what that's doing is that's going to actually go down here and bias this main spool. Right now you can see that the spool is cylindrical in nature, can slide back and forth. It has this big spring on here, but in terms of opening and closing, it's going to open and close based on this small pilot control over here. So solenoid opens, this is going to allow fluid to flow, and it's going to send fluid to either side of the spring to make it move back and forth. The idea about this is a couple different things. One, if you were to do this manually, you'd only be moving a relatively small valve. You wouldn't have to use like a big giant lever to move a large valve. So that is going to reduce the amount of force necessary. The other thing is that, for example, in this one, we're using solenoids. So this can all be controlled by a remote operator, or it could be controlled by a PLC or a computer controller, something like that. This is a relatively inexpensive device. And in addition to being able to control it remotely, you can also do a lot of sensing remotely and other types of automation functions. In terms of electrical operation, the most common type is a solenoid. We mentioned that a bunch of different times. Essentially, solenoid is essentially an electromagnet. When it is charged, the iron core here is going to slide back and forth. So if you charge the solenoid, you have a coil around this, and that creates a magnetic field, and the piston is going to move back and forth. This core is going to move back and forth. You want to move in the other direction, you power this solenoid, and it pulls it back in the opposite direction. In general, about 90% or more of all automated equipment uses solenoids to do these. Now, if you're dealing with a larger valve, solenoids are somewhat limited in terms of size because you can only generate that much force. You can actually use a linear electric motor where you actually charge the motor, and essentially that motor will move the plunger back and forth with the same basic concept, but it's a larger scale device. Now, in terms of holding position, the most common device for that is what's called a détente. That's a French term. It's essentially a little ball pressed into an indentation, and it prevents the valve from moving on its own, and in general it can have multiple locations. This idea of a détente is used in valves, but also used in a variety of other mechanical and even construction equipment and home products where you want to stop something in that particular location. Another way of holding a device in a center position, particularly a centered position, are springs. Right? This spring is going to push this valve back to the center. So this is referred to as a self-centering or spring-centering valve. This spring is going to push this valve to that side, and until it sees some form of pilot pressure, it's going to hold it in that position.